In this video, we're going to continue our discussion of the forces that stabilize molecules that interact together. So just as a quick recap of what we talked about in the previous video. All right, so we established the fact that it's Coulomb's law that governs the interaction between all of the molecules that we care about, any charged particle. Okay, so this graph that I'm showing here, the y-axis is the potential energy. This is our 0 point on our potential energy scale. And the x-axis is the radius, or the distance between two particles. Right? So if we think about the interaction between a positive particle and a negative particle, then Coulomb's law tells us that when we're really far apart, that there's not a very strong interaction, but as we start becoming closer together, this interaction becomes more and more favorable, or more and more negative. And Coulomb's law continues to predict that as we continue getting closer and closer to zero, the energy stabilizing these particles becomes exponentially or infinitely negative. But as we talked about, that's not actually true. Instead, we reach this minimum in energy that stabilizes the molecules, and we start then going back up towards positive potential energy because the molecules begin overlapping. And the distance where we have the most negative potential energy, so this radius corresponding to the most negative potential energy, is the distance or the radius that these molecules actually are in their most stable interacting form. Okay, so this explanation, Coulomb's law, really is the basis of one of our intermolecular forces, and it's our strongest intermolecular force, which is ion-ion. Okay, so as you know, ions are fixed charged molecules, right? So things like sodium cations and chloride anions, right? So when you have a sodium cation and a chloride anion coming together to interact, these form ionic compounds. And we often say ionic bonds. But the reality is that the interaction between a sodium cation and a chloride anion is not actually a bond. It's an intermolecular force. And that intermolecular force is ion-ion. Okay? So since we have a charged particle, a sodium cation, which has a positive charge, interacting with a chloride anion, which is a negative charge, right, and they're a certain distance apart, then this interaction is perfectly governed by Coulomb's law. So ion-ion interactions are perfectly governed by Coulomb's law. Okay, so if you understand what we talked about in the previous video, you understand ion-ion intermolecular forces. These are the strongest intermolecular forces. Okay? So that's the easiest to understand based on our discussion of Coulomb's law. However, all of the other intermolecular forces that we have learned about in the past, or will learn about today, are also based on this interaction between a positive charge and a negative charge. However, they can't be based purely on it, because then it would be ion-ion. So the next category is dipole-dipole. Okay, so this occurs between two polar molecules. So we have two polar molecules interacting. Okay, so let's just imagine a molecule here, right? So we have this compound, and if it's polar, that means that one side of it is partially negative. So we have a partial negative charge on this side, and on the other side we have a partial positive charge. Okay, so even though this molecule does not have a fixed positive or negative charge, right? So even though it's not a cation or an anion, it does have these permanent positive and negative charges, right? So we call it polar. And if this molecule comes into close proximity with another polar molecule that has a partially positive and a partially negative side, or terminus, then this interaction between a partial positive and a partial negative is it obeys the laws of Coulombic interactions, right? But the thing is, it's not quite as strong as an ion-ion interaction because this is not a full negative charge and this is not a full positive charge. So it's not as strong as an ion-ion, but it does still interact favorably. So let's go ahead and leave off here, and in the next video we'll discuss the third core intermolecular force, which describes the interaction between non-polar particles.